In alveolar exchange, also known as external respiration, the red blood cell uses the exact same chemical reaction but in reverse. Now the process is driven by the concentration of oxygen, which in the alveolus is high because it's just been breathed in. That high concentration of oxygen pushes the oxygen out of the alveolus into the plasma and blood. Some small portion of the oxygen travels dissolved in the plasma, but the vast majority of it goes into the red blood cell where it encounters hemoglobin, which is deoxyhemoglobin or bound to a proton. Because of the sheer amount of oxygen, hemoglobin changes its mind about being with the proton and says, hey, it was meant to be you for the rest of my life. I don't know what I was thinking, and so now it becomes oxyhemoglobin and releases the proton. The proton recombines with the bicarbonate, which was brought back into the cell in exchange for chloride going out into the plasma. The proton and the bicarbonate combine through carbonic anhydrase to form carbonic acid, or H2CO3, and that breaks down further into carbon dioxide and water. Carbon dioxide, having a higher concentration in the red blood cell or in the plasma than in the alveolus, readily diffuses from the cell to the alveolus. Carbon dioxide that was traveling bound to hemoglobin or to other proteins in the plasma, or just by itself dissolved in the plasma, also all diffuses into the alveolus because of the pressure gradient, which is similar to a concentration gradient.